Everyone, it's time for us to start section 2.5 on something called indeterminate forms. So we're going to continue our study of how to evaluate limits. And so in last section, we saw that the easiest way was through substitution. And so that says that basically if our function is continuous at x is equal to c, then we can very easily evaluate the limit as x goes to c if f of x is equal to f of c. So all we have to do is essentially substitute and essentially just plug in our value of c in, and that gives us our answer. So, it's not too difficult for us to just say something like, I'm just going to make something up on the spot here. X goes to 2 of, the limit is x goes to 2 of 3x squared minus 7x plus 5. Well, this is a continuous function, so the answer is just 3 times 2 squared minus 7 times 2 plus 5, whatever that simplifies out to be. So this is the easiest way to do things. However, unfortunately, most of the time in this class, I'm not going to be asking you limits of this form. Most of the time, our functions that we care most about are not going to be continuous at the point in question. So the thing is that if we don't have continuity, let me finish writing this up, our functions will not be continuous at the point in question. And so then the question is how to handle it. Well, we'll see in this section, our most important cases are going to be in something called indeterminate forms. So if we have an indeterminate form, which I'll have to tell you what that means in just a moment, we can usually algebraically manipulate the function that we're taking the limit of to get something where we can apply substitution. And so there are several different indeterminate forms that can arise in these in these questions. And so basically, what an indeterminate form means is that when you attempt to plug in x is equal to c, you get an expression that looks like one of the following forms. So there are several different indeterminate forms. And so sometimes we can end up with 0 over 0. Sometimes we can end up with infinity over infinity. Sometimes we can end up with something that looks like infinity times 0. And sometimes we can end up with something that looks like infinity minus infinity. So these are all indeterminate forms, and so what our goal is going to do is that we'll see that we have problems that we end up with one of these 4 indeterminate forms when we plug in x is equal to c. So that means that we'll have to do some algebraic manipulation, and then hopefully we'll be able to get something down so it is continuous, so we no longer have the indeterminate forms, and then we can apply substitution to evaluate our limit. So all 4 of these are important. The most important one for us is going to be 0 over 0. So let me go ahead and just show one example to wrap up this video. And so we'll see how we start off with something that we get 0 over 0. We do a small amount of algebraic manipulation, and then we can evaluate it. So first example, let's say that f of x is x squared minus 4x plus 3 over x squared plus x minus 12. And I ask you, what is the limit as x goes to 3 of f of x? And so from the previous section, we know that f of x is a ratio of two polynomials. It's a rational function. And so we know that this is continuous everywhere it is defined. And so we might think that, hey, we're able to apply continuity because apply substitution, and this function is continuous everywhere it's defined. So as long as it's defined at x is equal to 3, we're good to go. However, it would be a little bit too easy for that to happen, because we see if we plug in x is equal to 3 into the denominator, we get 3 squared plus 3 minus 12 is 0. So it is not defined at x is equal to 3. So substitution does not apply here, as f of x is not continuous at x is equal to 3. Okay, so our obvious thing to do is to apply substitution from continuity. We don't have that. So realize that if we plug in 0 into the denominator, we plug in 3 into the denominator, we get 0. But also we plug in 3 into the numerator, we get 9 minus 12 plus 3. We also get 0. So right now we have a 0 over 0 indeterminate form. So going back to this slide, we see that we have an indeterminate form, like 0 over 0. We want to algebraically manipulate our function so we can apply substitution. So what do we want to do here? Well, the limit as x goes to 3, we want to think about what ways we can algebraically manipulate it. So I might want to take a second to pause and think about that before I give away the answer. But let's see what happens if we factor the numerator and denominator. So we can factor the numerator into x minus 3 times x minus 1. We can factor the denominator into x minus 3 times x plus 4. And we're allowed now to algebraically manipulate this by, we can cancel out the factors of x minus 3 in both the numerator and denominator. And so we end up with the limit as x goes to 3 of x minus 1 over x plus 4. And now we have something that we no longer get issues when we plug in x is equal to 3. So we can just go ahead and apply and use the fact that now this is continuous at x is equal to 3, plug in x is equal to 3, and so our answer is just 3 minus 1 over 3 plus 4 is 2/7. So this is how this is one example of applying, of starting off with a 0 over 0 indeterminate form, doing a small amount of algebraic manipulation to something that we can apply substitution to. So this pattern is going to be something that we'll be doing a lot, both throughout the section, but then for the rest of Chapter 2 and quite a bit in Chapter 3, because these 0 over 0 indeterminate form limits will be occurring all the time. Just one little point that I want to make before I wrap up this video is that canceling out these factors x minus 3, we have changed the function here. So this function, f of x, is different than the function x minus 1 over x plus 4. Because this function is not defined when x is equal to 3. This function is defined when x is equal to 3. So we have changed the function. However, it is worth noting that limits only care about what happens close to x is equal to 3. So the fact that we've changed, that we have something different at x is equal to 3, but we're not changing what's going on around x is equal to 3, means that this is okay.